in this question we've got a whole lot of 3-digit numbers that are divisible by their last digit. So one way to represent a 3-digit number is just like this, ABC, and we put a line above it. And this is a multiple of its last digit. So there's some number m such that this is just m times by the c. If we don't want to write out this, we can just say c divides into this. This is just a fancy way of saying that the whole number is divisible by, is some multiple of c. Now, let's look at some properties of this. We have that c can never be equal to 0 because nothing is ever a multiple of 0 except 0. So none of the numbers can end in a 0. Now the question also says there are 8 of them that are consecutive integers. So these consecutive integers must be of the form AB1 up to AB8 or AB2 up to AB9. Any other 8 consecutive integers, one of them will end in a 0, so that's not a possibility. Okay. Now, in either case, one of these numbers ends in a 7, so that means that 7 must divide into AB7. Okay, that's the same as saying that AB7 is some unknown multiple of 7. Now, if this is a multiple of 7, I can subtract a 7 and it will remain a multiple of 7. Okay, doing it without this fancy notation, I can just subtract a 7 and we get it's still a multiple of 7. This over here is just 10 times by AB. And now the only way that this can be divisible by 7 is if this one is divisible by 7, because this has no common factors at 7. So therefore 7 divides into AB. Also, we can do the same thing with 3. One of these must end in a 3, and eventually we'll get that 3 divides into AB. We can do the same thing with a similar thing with 8. 8 divides, or basically we've got one of them is AB8. That will mean that 8 will divide into AB0. This over here is just equal to 10 times by AB. This has one factor of 2 in it. That means the other 2 factors of 2 must be in this one. So we'll get 4 must divide into AB. And if we combine these statements over here, we get that 84 must divide into AB. So it's a multiple of 84, and the only 2-digit number that's a multiple of 84 is 84, so therefore AB is 84. And we still haven't figured out which one of these 2 cases apply. Well, what I could do is I can try this case where the last one is that, and I can check, is this a multiple of 9? Let's just calculate the sum of the digits, which is 8 plus 4 plus 9, which is certainly not a multiple of 9. So this case is impossible, and we have this case, and in this case the smallest number is 841. And the sum of these digits is just 13. for the next question, this is supposed to hold for any value of n. So that means I can replace n with whatever I want and it should work. Also, I want the f of 2021. So I'll replace n with a value that gives me the f of 2021. The most obvious thing, I can replace n with 2021 and we get 2021 minus 2021 times by the f of 2021 minus the f of 2021 minus 2021 equals 2021. Simplifying, this becomes just a 0, okay, which is annoying. This over here just becomes the minus f of 0 is 2021 which is f of 0 is minus 2021. Okay, that didn't seem to lead anywhere. Now we can replace n with 0 and we'll get that minus 2021 when this is 0 times by the f of 0 minus the f of 2021 equals 2021. And conveniently we just had found what the f of 0 is, so I can substitute it back in. This becomes 2021 squared minus the f of 2021 equals 2021, and rearranging we get this becomes 201 squared minus 2021 equals f of 2021. Okay, now the trick over here is not to multiply this out, but rather just to factorize this right here, and this just becomes, I take out a factor of 2021 get 2021 times by minus 1, and that is the same as this answer here. Okay, now there is another answer very similar, so it'll be worthwhile just to double check your calculations, because it can be easy to maybe make a mistake and make a sign mistake. So somewhere you should have been writing a plus instead of a minus, or minus instead of a plus. Yeah, that's kind of annoying, but that's the way it is. Okay, for this question, it's usually useful to draw a line from the center of the circle to a point in the circle that's also a point in the square. So we get this, and for this triangle we'll be able to use Pythagoras, and I can also draw in this, and for this triangle I can also use Pythagoras. Let's just make this length over here x, then this length will be 16 minus x, this length is 16, this length is 16, and this is halfway through here, so this is 8. Then we've got two equations for the radius, and these two equations should be equal, so we get radius squared is equal to 16 minus x squared plus 16 squared. It's also equal to 16 plus x squared plus 8 squared. This just becomes 16 squared plus 32x plus 8 squared, plus x squared, equals 16 squared minus 32x plus x squared plus 16 squared. One of these 16 squares cancel, this x squared cancels. Then I can take this to the side, this becomes 36 64x. I can take this to that side. That just becomes 8. Sorry. This is just 4 times by 8 squared minus 3 times by 8 squared. Minus 8 squared. Don't know what's wrong with me right now. And this just simplifies down to 3 times by 8 squared. I can divide by, which is just 64. So we get just x is 3. And then I can solve for r squared. R squared is just 19 squared plus 8 squared, which is just 452. The area of the circle is just pi r squared, which is just going to be 452 times r pi. And the answer is that.